So in lesson number 1, we looked at linear quadratic equations. So we looked at when a straight line intersects, or if it does intersect a quadratic equation. What we look at in this section is quadratic equations. So in a quadratic system, you have both equations are quadratics. So again, there are two ways that you can solve these. You can solve them graphically and you can solve them algebraically. The difference between the two methods is if you solve algebraically, you're always going to get the exact answer. Whereas if you solve graphically, you're going to sometimes get a decimal approximation. So you have to look at what the question is asking for, if they want the exact solution or if they're okay with finding the solution to the nearest hundredth or the nearest tenth. So if I was to use an algebraic technique, the way that I would do that is if I have two quadratic equations, y equals 6x squared plus 7x minus 4, and y equals 2x squared minus x plus 1. If I'm solving these algebraically, if y equals this and y equals that, in the solution, the y values would be the same. So what I could do is I could let the two equations equal each other. So I could have 6x squared plus 7x minus 4 equals 2x squared minus x plus 1. What do you think my next step would be? Just the 2x squared or everything? So if we moved everything, it would be subtracting a 2x squared, adding an x, and subtracting a 1. So 6x squared minus 2x squared?
4x.
7x plus x?
8x.
And negative 4 minus 1?
Negative 4.
Okay, so now I have a quadratic that equals 0. So what would I do next? Factor it out. So when you can factor it out, you could do the decomposition. Two numbers that multiply to negative 20 and add to positive 8. 10 and negative 2. So I could rewrite this 8x as a negative 2x and a positive 10x. And then I factor by grouping. So I group the first two together. What's common to 4x squared and 2x? And what would I be left with?
2x minus 1.
And what's common to 10x and negative 5?
5.
And if I've done this correctly, the hope is that I would get a 2x minus 1 again, which I do. So then my factored form is a 2x minus 1 and a 2x plus 5. I could have factored this the inspection way by recognizing the only way I'm going to get a negative 5 is to multiply a 5 and a 1, and then I could have kind of guessed my 2 at my 4. Because really the only way I'm going to get a 4 is 4 times 1 and 2 times 2. Okay, so now to solve to find the zeros, what values of x could I have for each of my factors? So if I let 2x minus 1 equal 0, what would x equal? X would equal 1/2. And 2x plus 5, x would equal
Negative 5.
okay. That gives me my x values. In order to find the solution to the entire system, I need to find the y values. So when I go to find the y values, I just pick one of these two equations. I'm going to pick probably the bottom equation just because it's the numbers are smaller. So if x equals 1/2, I get 2 times 1/2 squared minus 1/2 plus 1. What'd you get, Rachel?
I got 1. I feel like it's fine. I got 1.
Okay, so now you don't feel like you're wrong anymore?
No.
So then the solution would be 1/2 and 1. That's going to be an intersection point on the graph. And then I can do the same thing with my -5/2. Y equals 2 times -5/2 squared minus -5/2 plus 1. So what did you get this time? 16. So then the other solution would be -5/2 and 16. And those two solutions would have been the same if I had grabbed the 6x squared plus 7x minus 4. If I had put 1/2 into this equation, I would still get 1. So it doesn't matter which equation you choose. Okay? So then it says, sketch the equations on the grid and use a graphing technique to determine the solution to this system. State an appropriate window. So what I would have to do, grab my calculator. So y equals 6x squared plus 7x minus 4. And then 2x squared gets minus x plus 1. So right now I think I have a standard window setting. If I go zoom 6, there's my first quadratic, and there's my second quadratic. So from here I can see one of the points, but I'm really having a hard time seeing the next intersection point. So what I'd want to do is adjust my window settings. So my window, I probably don't need to go up to 10, so I could go from -5 to 5 is probably plenty. And then my y's, I don't need a lot of my y's. I could go maybe -4 and then go up to 20. And then see what that does. Because really what I'm looking for is these two intersection points. Okay? So now that I can see the two intersection points, if we sketch the graphs, this graph right here, that was my 2x squared minus x, or sorry, plus x minus 1. So we'll sketch that one first. And we need to label it so that we know which graph is which. This would help if I labeled it correctly. Minus x plus 1. And then I can label my 6x squared plus 7x minus 4. So minus 4, I know it's going to cut through here. And it tends to, it's kind of like this. It's far skinnier. So that's my y equals 6x squared plus 7x minus 4. And then I'd find these two intersection points, which I can find using that calc feature. Okay, so again, to find those intersection points, second calc intersect, and then I need to move along. So there's my cursor, so I probably want to move back up. Oops. So I'm closer to that intersection point. Enter 3 times, and there's my negative 2.5 and 16. So this point here is my negative 5/2 and 16. And this point right here is my 1/2 and 1. Okay. Finally, verify that the solution obtained satisfies both equations. So I have the one equation, which is y equals 6x squared plus 7x minus 4. So I would start off by y is 16 and x is negative 5/2. So I would substitute in my negative 5/2. Let's see, 5/2 squared is 25/4. 25 times 6 is 150, right? So 150 quarters becomes 75/2 minus 35/2 minus 4. So 75/2 minus 35/2 is 40/2, which is 20, and 20 minus 4 is 16, which I could have done all in one step on my calculator. Okay. And if I do the same thing with my other point, I have that y is supposed to equal 1 when x is 1/2. So again, 1/2 squared is going to be 1/4. 1/4 times 6 is 6/4, which is 3/2. So I have 3/2 plus 7/2, which is 10/2, minus 4, which is 8/2, gives me 2/2 or 1. And I would do the same thing with the other equation, but we kind of did that up above when we were solving it, so I'm not going to go through that again. So your questions. So question 1 and 2. Question number 2 just asks you to kind of figure out what would a quadratic system look like if it had 2 solutions, 1 solution, or no solution, or an infinite number of solutions. Okay? And then question number 3, and then 6 to 10 are the multiple choice and numerical response.